Welcome to my channel, TheTalk. Today we are going to solve the exercise questions of the chapter Real Numbers. So this is the question 2 in the exercise 1.1, which says that show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5 where q is some integer. So according to Euclid's division lemma, A equals to B multiplied by Q plus R, where R lies in the range between 0 plus 0 to B. So we will start substituting the value of B as 6 because in the question all of the expressions are in the form of 6q plus 1, 6q plus 3 and 6q plus 5. So all of these have B as 6. So when you substitute B as 6, you get the equation as E equals to 6 multiplied by Q plus R. Let's start substituting the remainder values now. So starting from 0, so if R equals to 0, A will be equal to 6 multiplied by Q. Now let's check whether 6Q is an even number or an odd number, as in the question is asked that we have to verify that odd integer is in the form of the expressions given. So if something is said to be even, it has to be divisible by 2, and if something is said to be odd, it is not divisible by 2. So when you consider 6q, so 6 being divisible by 2, that means that 6q is an even number. So this is even, and A equals to 6q plus 1 when R equals to 1. So in 6q plus 1, only 6 is being divisible by 2, but 1 is not divisible by 2. So 6q plus 1 is an odd number, which says that this is an odd number. And continuing, if R equals to 2, the equation becomes 6q plus 2, where 6 will be divisible by 2 and 2 will also be divisible by 2, so making it an even number. So and similarly, if you continue further, 6q plus 3 will be an odd number and 6q plus 4 will be an even number. So from these equations, we can say that the numbers 6q plus 1, 6q plus 2 is an even number, 6q plus 3 is an odd number. Then continue that A equals to 6q plus 5 when R equals to 5, because 6 is being divisible by 2 and 5 is not being divisible by 2, this is an odd number. So all the odd numbers are in the form of 6q plus 1, 6q plus 3. So this is the third question in the exercise 1.1. The question says an army contingent of 616 members is to march behind an army band of 32 members in a parade. So the two groups are to march in the same number of columns. So what is the maximum number of columns in which they can march? Total number of people in the march are 616. And there is another group of band having 32 members who are marching behind them. So both of these are clubbed together and you are supposed to find out the maximum number of columns in which they can march. So whenever you have to find the maximum of anything, the maximum possible combination of anything, we find the HCF of two numbers. So we will be applying Euclid's division lemma to find the HCF of two numbers 616 and 32. So as 616 is the bigger number, this is going to be the dividend. So when you apply Euclid's division lemma, 32 will be the divisor. So 32 divides 61 one time and 32. So when you subtract, you will be getting 29 here. You bring down 6. So 296. Maybe we can continue till 32 times 9, which is 27 and 18, 288. So this is 288. We are left with a remainder of 8. So the Euclid's division lemma statement says that we have to keep on continuing the division until we get the remainder 0. As the remainder is not equal to 0, we continue further. Now the dividend is going to be 32 and the divisor is 8, which is the remainder from the previous step. So 8 divides 32 perfectly 4 times. So 8 times 4 is 32, which leaves the remainder of 0. So as remainder is 0, we can stop our division here. According to Euclid's lemma, it says that whatever is the divisor that leaves the remainder 0 is the HCF of two numbers. So HCF of 616 and 32 is 8. Therefore, the maximum number of columns in which they can merge together is 8.